All right, welcome to Lightning Talk number, is this number 7? 1, 2, 3, 4, that sounds about right. This is Jason Coposky, the iRODS Consortium. He's got a talk that we just made up, he made up.
Literally just made up.
Cloud native iRODS, that sounds amazing.
I don't even know what that means. All right, so the general idea about this is, and I'm going to call this a mental model and aspirational, if you will, but iRODS has been increasingly deployed in these cloud contexts. We've seen the vast film machinery that BMS has crafted. And it got me thinking that, with these, cloud functions and Lambdas and containerized microservices and Kubernetes and whatnot, that it might be interesting to try to reformulate iRODS, as a technology in a way that would be much better packaged for these environments. Which, if we can build a Lambda and, a one dedicated container for iRODS, then it would also ease this deployment issue where we have all these shared objects and the other plug-in machinery around iRODS all put together in a nice, neat fashion, and which will allow for automated deployment. If there's just a button in Amazon where you can deploy another iRODS zone because it'll stand up an RDS instance and then give you a load balanced access to these Lambdas, that would be quite powerful. So how can we repackage this thing in a way that would be better for containerized environments? And this would also give us the ability to simplify what the client API would look like. And we'll talk about a little bit of that later. And once again, state remains the enemy when we're building these, highly distributed, highly scaled out environments. So I got to thinking about this and have come up with a couple simple steps that are going to get us there. So the first of which is how are we going to get, the existing clients to be able to interact with a cloud deployment of iRODS? And so the first of which is that we're going to extend the list of roles within the server. So we have catalog service provider, the catalog service consumers, and then we would have a proxy role, in which basically a client will connect to iRODS. It'll spin up an agent, and the agent is going to, as it always does, inspect its role, and then repack all of that C packing instructions back into the XML protocol, possibly base64 encode that in order to simplify transport, and then just hit a curl request to a configured endpoint and basically forward the request to the cloud deployment. So this will allow on-premises clients to work with cloud deployments like iCommands, the NFS rods, DAV rods, and all of these other things that we've been talking about right now. It'll help us bridge that gap, in the technologies. Now, since the REST API and these cloud native deployments will have to be much less stateful, if you will, proxy agents are going to be responsible for maintaining a lot of the semantics that iRODS provides now around the POSIX interaction, where we have persistent information and the L1 descriptor tables down here, where when you go back out for another read to an agent, it just looks for the existing state, and then all the offsets and everything are preserved and whatnot. And like I said, as we're assuming that the HTTP requests are going to be atomic in nature. So that also means that we're going to have to repackage for the proxy read and write operations into new, more cloud-friendly, API invocations using, the next generation API that we have been testing right now. So that would be step one. Step two is entirely Marcus's job, where we have to basically build a development environment which will allow us to statically link all of this stuff, because Amazon Lambdas and whatnot expect everything to be packaged into one thing before it is installed and created within the cloud environment. And so, we're going to have to get all of the external dependencies sorted out. And I think a lot of that work is already in flight right now. And then from there, once we have that build environment put together, we can take all of the innards of iRODS in step 3 and stick that into a Lambda runtime. So there are plenty of examples out there where we can effectively take the request coming in over HTTP, possibly base64 decode that, and then take that XML and then just pass it right along to proc API request as if it had just come over the 1247 port. Now, this gets into some interesting assumptions when we're talking about deploying something like this in the cloud, where we have to assume that one, the catalog exists somewhere else, And I completely skipped over this very important step here where we have to get the configuration from somewhere else. So as I've mentioned in the REST API, we now have a service that'll serve the configuration to all of these different agents that are going to be standing up, because we can't pack all of that stuff into an environment variable, for instance. And then from there, we make assumptions that the catalog is going to be hosted in some other service like RDS. And this would be external to Kubernetes as well, or if you have a on-prem cloud deployment. The new executable assumes it's the catalog service provider because everyone is basically an island in a standalone environment. And all the resources are going to assume to be cloud native as well. So everything is going to have to operate in detached mode, much like S3 does, because every instance can assume that it has access to those resources. And we'll have to, pull that behavior out of the S3 plugin and apply that to Unix file system plugin if you happen to have any NFS mounted resources, exported to Amazon, or if you happen to have elastic block storage or something like that. So this very much simplifies a lot of the mental model around, iRODS. And I believe this is also going to work on an on-prem, off-prem solution where effectively you can, bless the proxy as the catalog service provider for any on-prem resource servers that you happen to be running, and it'll just simply treat that proxy like it's the catalog. And step 4, moving into the glorious future, is that the experimental iRODS API that we're working with right now is all driven by JSON, much like the policy composition is. And this is going to lend itself well to a Lambda-like deployment. And this is going to give us the ability to, as I said earlier, take the iRODS CLI and newer clients that are written with that and migrate gradually to this new API, which we have been calling 5.0 for, I think, the past decade at this juncture. And we'll be adding, extending that API to add some, what I've been calling read some, write some style API interfaces, which are basically going to be atomic in nature and not need the persistence that current clients will need to work directly with an HTTP style API. And that is the end of my talk. Questions, comments, criticisms, complaints?
You're not going to flip over and show us the demo you had? You don't have a demo?
Yep, not yet.
So we do have a suggestion for consider rewriting step-by-step in Go. What do you think about that?
Oh, that sounds really exciting. Yeah. I mean, the issue there is that we have a lot of code deployed out there everywhere, and we're going to need this bridge that involves all of the other arcane things that are supported in the legacy API, like how we're currently handling bulk transfer, for instance, which hasn't seen the light of day at this juncture. So a lot of the existing clients out there will fall over without having all of the legacy stuff deployed first. And that's where we get to the step of moving to the new JSON-driven API.
Right. And I don't know, I think we demoed that last year, maybe. I don't know if we did or not.
I believe Corey did a lightning talk around the CLI.
I think that's.
Is that true, or am I making that up? Corey does a lot of lightning talks.
It sounds familiar. Let's see. We have, yes, people are very excited about not having high ports also, so that's good. Excellent. Thank you.
All right, thank you.